Okay, when we talk about time of flight, what does time of flight simply mean? It's very simple when we talk about time of flight. Now, imagine a body is being projected from this place. Let's say a javelin. Somebody takes a javelin and throws it like this. Something happened. The body goes up like a javelin. Let's say a javelin thrower, for example, or a hammer thrower. So the body it goes this way. Now it gets a certain max height because it cannot keep going forever. Now, as it's going up, it's covering distance along x and also distance along y. Somebody projecting the javelin like this. So it gets a max height. At max height, it cannot go beyond this level. That's the first phase. So the phase one is the phase of max height. That's it here. The phase of maximum height, whereby the body is not going to go beyond that level. It loses all its initial velocity along the y-axis. So at this very point in time, the body starts falling. Gravity now takes over and sends it back to the ground. So you see a body is being thrown from here. The body goes like this and hits this region. So that's that. So we're talking about time of flight. You have time of flight, two type of time of flight. You have the time of flight, it takes the body to get to maximum height. And the time of flight, it takes the body to move from that maximum height back to the ground. Now, provided there is no air friction, provided there is no wind or there's no air friction, for example, it means it's going to take it the same exact time of flight, the same exact time I need to get the maximum height. It's going to take that same time to fall back. So it take it 2 seconds to get to the max height. It's going to take it another 2 seconds to fall back. So the time of flight is simply the time it takes a given projectile, which is a body, to get to the max height, and also the time it takes that same body to fall back to the ground or to the earth. So let's look at it. Don't forget, we're going to be needing the knowledge of, SOHCAHTOA, very important. So this is initial speed. Yeah. So for the fact that body is being shot with this velocity, it means it's going to move in 2 dimensions. That's what I call it, two-dimensional motion. So at initial speed, so the body does this against the horizontal theta. So the body is going to cover 2 dimensions, one along y-axis and one along x-axis. Now don't forget SOHCAHTOA. Opposite, hypotenuse, adjacent, very important. So uy over u, opposite by hypotenuse, is sine theta. So uy is u sine theta. So the initial velocity of the body along y-axis is u sine theta. So let's see that for along the x-axis. So ux over opposite hypotenuse adjacent. So adjacent over hypotenuse equal to cos theta. So we cross multiply. Ux is u cos theta. So this is the initial velocity of the body along the x-axis. So that means immediately the body was projected, it experiences two kinds of